Welcome back, everybody. This is our 14th class in JEE Mains previous year questions for chapter Moving Charges and Magnetism of class 12th. Before this video, we have made 13 video in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for neet previous year questions. So if you find those useful, then you can like the video, share them as much possible, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With your donations, we will be keep on making these videos and bringing you on the regular basis. So with this, let's start today's video. And then the previous one, I think we covered up to around 95. This is 94th. This is 95. Now let's start with the question number 96. So here a galvanometer of resistance G is converted into a voltmeter of range 0 to 1 volt by connecting a resistance R1 in series with it. Additional resistance R1 in series with it. The additional resistance should be connected to in series with R1 to increase the range of the voltmeter to 0 to 2 volts. So initially we have a voltmeter with range 0 to 1 volt with resistance R1 in the series. So the initial circuit will look like something like this, that we have a R1 resistance. Here we have a galvanometer, and galvanometer also have its resistance, that is we can say G. So now this system gives us we can say reading from 0 to 1. So if the system is showing us reading from 0 to 1, it means the potential difference or the potential drop across resistance R1 and the galvanometer is 1 volt. So we can say if this is point A and this is point B, and here is some current that is flowing in the galvanometer, that is Ig. This current will stay constant because this galvanometer has a maximum value of current for its maximum deflection. We cannot go beyond that. So current in this galvanometer will stay the same. So from this we can say VAB is equal to 1 volt, and from that we can find out Ig, current in the galvanometer, is equal to VAB, that is 1, and this one is we get from here that range is 0 to 1. So it can maximum it can measure 1 volt, so we are taking that value divided by the total resistance, that is R1 plus resistance of galvanometer, R1 plus galvanometer. Now it is mentioned that we have to connect a resistance R in series, additional resistance R. So let's say this is additional resistance R. We already have R1 and we already have galvanometer here. And this is our point P. Here we have point A, and now it is said that it should be able to measure 2 volts from 0 to 2 volts. So now if I add a point here C, and assuming this R is also now part of the galvanometer, so we can write this circuit like this, because R and R were in series. So we have C here, this will be R plus R1, galvanometer here, and point P here point C. So now this system should be able to measure up to 2 volts. So but current will stay the constant because galvanometer's current it cannot exceed maximum value of current, and VCB is given to be 2 volts. So value of Ig now comes out to be 2 by R plus R1 plus G. Now this value and this value should be equal. Comparing both of these, so 1 by R plus G is equal to 2 by R plus R1 plus G cross multiplication 2R plus 2G is equal to R plus R1 plus G. Sorry, it is R1. From here it is R1. So we can say R is equal to R1 plus G. Option D will be the right answer here. Moving to the next one. Galvanometer used in laboratory for detecting the null point in electrical experiments. If on passing a current of 6 milliampere, it produces deflection of 2 degree, its figure of merit is close to. So we can say here that 6 milliampere is producing deflection of 2 degree. Now 1 milliampere will produce deflection of, oh sorry, not 1 milliampere, 3 milliampere. 3 milliampere will produce deflection of 1 degree. And we have to find out figure of merit. So figure of merit is known as amount of current required to produce unit degree slash division deflection. So here we have scale in degrees. Mostly for galvanometer scale will be in degree because it is a rotational scale. So the amount of current that is required to produce 1 degree of rotation is the figure of merit, and from here we know that for 1 degree we need 3 milliampere. So it will be 3 into 10 raised to power minus 3. Option D will be the right answer here. Let's move to the next one. Galvanometer has 500 tons, so N is 500. And area of each turn is 3 into 10 raised to power minus 4 meter square. Torque required 1.5 newton meter to keep the coil parallel to the magnetic field when value of current is given 0.5 ampere. So we have to find out strength of the magnetic field. So as we can get the idea from the torque that it is mentioned that torque is required to keep the coil parallel to the magnetic field. So if coil is parallel to the magnetic field, we can say coil will look like something this. That suppose this is our coil and our magnetic field is something like this. The plane of the coil is parallel to the magnetic field. Now, magnetic dipole moment of the coil, we know that will be, let's first write down the formula. We know that torque on a current carrying loop is given by m cross p, where m is the magnetic dipole moment and magnetic dipole moment is perpendicular to the area. And here for this loop, magnetic dipole moment will be something like this. So angle between here M and B will be 90 degree. So torque will be MP sin 90. Sin 90 is 1. Value of torque is 1.5. M is I times area. So 5 by 10 into area, that is 3 into 10 raised to power minus 4. Multiply the number of turns, that is 500. So this is the value of magnetic dipole moment into magnetic field, which we will find out. So this will be okay, not like this. 1.5 we can write 15 by 10 and it will get cut, and 5 into 3 15, so this will also get cancelled. We will have B is equal to 10 raised to power 4 by 500 over 10 raised to power 2 by 5, that will be 20 Tesla. So here we will have 20 Tesla. Moving to the next one. So a galvanometer of resistance 100 ohm and 50 division on its scale sensitivity. So first let me slide it down so that I should have sufficient space. So scale sensitivity is 50 microampere per division. Means for one division 20 microampere current is needed and it has 50 divisions. So means current of the galvanometer or max current will be 20 into 10 raised to power minus 6 into 50. That will be 100,000. So 10 raised to power minus 3 ampere. That is the maximum current in the galvanometer. It is to convert it into voltmeter of three ranges 0 to 2, 0 to 10 and 0 to 20 volt. Appropriate circuit to do this. Now to convert a galvanometer into some voltmeter of with certain range, we know that basic diagram is something like this, that this is our additional resistance and we have a galvanometer here, and these are our 2 points A and B. Now these two A and points A and B defined the range, that how much potential will be needed to be measured. So as per the first case, we need to measure 2 volts. So VAB is equal to 2 volts and IG is known to us, the current that can flow through the circuit. It is 10 raised to power minus 3 ampere, and resistance of the galvanometer, that is RG, is equal to 100 ohm. So now using these two values, we can say IG is equal to VAB divided by R plus RG. So 2 divided by, sorry, not 2, 10 raised to power minus 3 is equal to 2 divided by R plus 100. So solving this, we will get R plus 100 is equal to 2 by 10 raised to power minus 3, that will be 2000, and R comes out to be, or we can say R1, it is R1 comes out to be 190 ohm. So if we compare the options, then our first option A get cancelled out because here R1 is 2000. Option D is also get cancelled out because here R2 is R1 is 19900. So now let's come into R2. As we can see from the diagram that when we connect R2, R1 is already connected. R2 is not individual resistance. R1 is already connected in the series when we are measuring, we are making it from 0 to 10 volt. So our new circuit is something like this, that we have R2 here. In series we have R1 also available. We have a galvanometer and these are our points A and B. And again we have some maximum current. So now our formula will become IG is equal to VAB by R1 plus R2, that was R1 plus R2 RG, and now we have to measure 0 to 10 volts. So this becomes 10 volts, but IG stays the same, that is 10 raised to power minus 3. So 10 raised to power minus 3 is equal to 10. R1 is known to us already, that is 1900 plus R2 plus 100, that is galvanometer resistance. So solving these, but we will get, this is 2000 plus R2 is equal to 10 by 1000, that will be 10,000. So from this R2 comes out to be 8000 ohm, that is option. In option C we have R2 as 8000 ohm. So, and in in B we have R2 as 19900. So that is that will be not the right answer. So option C is the right answer here. Moving to the next one. A moving coil galvanometer having resistance G produces full scale deflection when current Ig flows through it. The galvanometer needs to be converted into ammeter of range 0 to I node, where I node is greater than Ig, by connecting its shunt resistance Ra to it and into a voltmeter of range. So we have to convert into two things. First into a, we can say, first into a meter and second into a voltmeter. So we will separately solve both cases. So first conversion into ammeter. So we have a galvanometer and its full scale deflection is happens at Ig. So galvanometer is here and we know its maximum current can be Ig, and to convert it into galvanometer what we need, we will add a shunt resistance Ra as mentioned. So and we have to find the values, I think. Now we know this galvanometer has some resistance of its own that is known as Rg, and if I node current is flowing through the circuit, that original current is I node because we have to measure 0 to I node. So suppose maximum current I node is flowing in the circuit, then only Ig can go through the galvanometer. So remaining should go through the this resistance Ra. So the remaining current will be I node minus Ig. This will be the current in the current through the Ra arm. Now, as both in parallel, so potential across both of these should be equal. So potential across galvanometer is current into its resistance, that is Rg, and potential across Ra is equal to current into resistance. So I node minus Ig into Ra. So solving this equation, here we will have Ig plus IgRA equal to I node Ra, and from this we can say, okay, we have to find value. From here we can find value of Ig. So Ig will be I node Ra divided by Ra plus Rg, where R is the parallel shunt resistance in case of ammeter. And R, here in the option we can see that we have Ra and Rv. Ra is the shunt resistance in case of ammeter, and Rv is the parallel series resistance in case of voltmeter. So first we now we have to solve for the voltmeter and then we can find out the relation between them. Now for voltmeter. So in voltmeter resistance had to be added in series. So this is Rv. We have a galvanometer and current Ig will be flowing through the circuit, and range is 0 to V. So AB, we can say VAB is equal to V, and V is equal to given to Zi node. Okay, now from this circuit, value of Ig is equal to VAB divided by total resistance, that is RV plus RG. We know VAB is equal to V is equal to GI node. So we can say IG becomes out to be Gi node by Rv plus Rg. And now from this equation, suppose this is equation 1, this is equation 2. Both these equations should be equal. So equating both of these, what we get? We will get Gi node divided by Rv plus Rg is equal to I node Ra plus Rg. So I node get cancelled, cross multiplication. G R A plus G R G is equal to R A R V plus R A R G. Now let's find out what this G is as mentioned in the statement. Okay, so here G is the galvanometer resistance which we have taken as Rg. So we can write Rg as G. Wherever we have written Rg, we can write it as G. So this equation will be converted to Ra plus G, and in this equation we can write Gi node Rv plus G, and here whenever we have Rg we can write it like G. So this will stay as it is. Rg is equal to G, so it will be Z square RARV plus RA into RG, so RA into G. So GRA, they get cancelled, and we have a relation that Z square is equal to RARV. So let's compare, and we can see from here that G square is equal to RARV, and in option D and in option B we are getting this relation, means option A is cancelled and option C is cancelled. Now let's move to the next part, that we have to find out ratio of RA and RV. Now to find ratio of RA and RV, we need to have their values. So value of RA can be extracted from this equation, and value of RV can be extracted from this equation. So let's write them separately, both of these equations, and then try to solve. Let me copy this one and paste. And the second equation we have, that is this one. And paste it. So let's now solve this equation to find a value of RA. So from this one we can say, as mentioned, that Ig is equal to I node Ra by Ra plus G. From this, IGRA plus IgG is equal to I node Ra, and from this we can say IgG is equal to I node minus Ig into Ra, and Ra is equal to IgG by I node minus Ig. This is for Ra. Now for Rv, Ig is equal to G I node Rv plus G. From this, Rv plus G is equal to Gi node by Ig, and Rv comes out to be Gi node by Ig minus G, and this can be further written as G common I node minus Ig by Ig. Now we can divide both of these two equations, this one and this one. So we will get Ra by Rv is equal to Igg divided by I node minus Ig. Here we will have G I node minus Ig with Ig. So G get cancelled and we have here Ig whole square divided by I node minus Ig square. So it will be Ig divided by I node minus Ig whole square. So now let's compare, and we are getting this result in option B. So option B will be the right answer here. Now let's move to the next one. A moving coil galvanometer allows full scale current of 10 raised to power minus 4 amperes, means value of Ig is 10 raised to power minus 4 ampere. Series resistance of 2 mega ohm required to convert it into voltmeter of range 0 to 5. Therefore, value of shunt resistance required to convert into the above galvanometer into ammeter of range 0 to 10 milliampere. So it is mentioned that if we convert this galvanometer into voltmeter, then it will be converted from 0 to 5 with 2 mega ohm resistance. So using these two values, what we can find out? We can find out resistance of the galvanometer. So let's draw the diagram that we have a 2 mega ohm or 2 into 10 raised to power 6 ohm resistance, and we have a galvanometer here and A and B points. Now difference between A and B points potential is 5 volts. So current in this circuit will be 5 divided by total resistance, that is 2 plus 10 raised to power 6 plus resistance of the galvanometer is equal to current of this circuit, and maximum current through galvanometer is mentioned already, that is 10 raised to power minus 4. So using these values, it will become 5 into 10 raised to power 4 is equal to 2 into 10 raised to power 6 plus G, and from here we can see that G will be 5 into 10 raised to power 4 minus 2 into 10 raised to power 6, and we know that this term is bigger and this term is smaller. So from this, G comes out to be negative, and resistance can't be negative, means there is problem in the statement. There is something missing in the statement, or some value is incorrectly defined. Moving to the next one. Moving coil galvanometer has a resistance of 50 ohm and it indicates full deflection at 4 milliampere current. So Rg, resistance of galvanometer, is 50 ohm and current Ig is equal to 4 milliampere. Voltmeter made using this galvanometer and a 5 kilo ohm resistance, maximum voltage can be measured. So we have to find out that what is the maximum value of voltage which can be measured if we add a 5 kilo ohm resistance in the series with this. So let add, this is 5 kilo ohm resistance. Here we have galvanometer and these are our 2 points, measuring point A and B. Now we have to find out VAB, that this is we have to find out, and we know that maximum current can flow is equal to IG. So IG will be equal to VAB divided by the total resistance, that is 5 into 10 raised to power 3 of the added resistance plus galvanometers is, it is 50. Now this is 5000 and this is 50, so we will ignore this 50 just so that our calculations can become easy. Now Ig is 4 into 10 raised to power minus 3, multiply this value ignoring 50, that will be 5 into 10 raised to power 3 is equal to VAB, and it will be 20. So VAB will be 20 volts. That is option C for us. So with this, we end this video here. Hopefully whatever we have covered here is helpful to you and understandable also. Again, if you have any doubts or suggestion, you can put them in comment section. I will try to resolve them and or implement them. And if you like this video, then do press the like button, share it as much as possible, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. So with this, again, thanks for watching, and we will meet in next video.